Hello viewers, and welcome once again. We are still under logic. We have entered into Cry the Almighty God's algebra. In this Cry the Almighty God's algebra, we are going to deal with logical equivalent. That means law and the grace. That means logical equivalent and logical implication. That means we're talking about law and the grace. We are going to deal with them under this subtopic called Christ Almighty God's algebra. Let us start. We are going to start with first Ejike's law. First Ejike's law. Let us start. First Ejike's law. First Ejike's law. P or Q is equal to Q upon not P equal to not P implies Q. This is a typical example of first Ejike's law. P or Q is equal to Q upon not P also equal to not P implies Q. This is a typical example of first Ejike's law. You will see that this P or Q is a disjunctive statement, which we transform it to conditional statement. That means how not P implies Q. So it is logical equivalent, that it is law. It says that whenever P or Q is true, also not P implies Q is also true. That means whenever P or Q is true, also not P implies Q is also true. In the same vein, whenever not P implies Q is false, also P or Q is also false. You say it is logical equivalent. Despite the syntax are not the same, but the semantics are the same, you say it is logical equivalent. This Q upon not P is the same thing as not P implies Q. It's the same thing as not P is on Q, not P implies Q. That means Q upon not P. So whenever we use Q upon not P, you know that it will mean not P implies Q. So let us prove this statement that it is true that P or Q equal to Q upon not P equal to not P implies Q is first Ejike's law. Proof. Suppose P or Q is equal to not P implies Q. We actually remove Q upon not P to avoid tautology and also to manage our space. That's why we remove Q upon not P, being that it's the same thing as not P implies Q. It's the same thing as not P implies Q. Is a conditional statement that put in this form. That's Q upon not P. So we remove it so that we will manage our space. We assume that P or Q is equal to not P implies Q. And in this statement, as I said earlier on, is a logical equivalent. In the sense that whenever the left answer of the equation is true, also the right answer of the equation is also true. In the same vein, whenever the right answer of the equation is false, also the left answer of the equation is also false. We say it's logical equivalent. Since this statement is logical equivalent, is our assumption is logical equivalent, that must our hypothesis. Since it is logical equivalent, we can transform it to bi-conditional statement, and it will still preserve logical equivalent. If and only if P or Q, if and only if not P implies Q. We have seen that we have now transformed it to bi-conditional statement. It says that whenever left equivalent is true, also the right equivalent is also true. Whenever the right equivalent is false, also the left equivalent is also false. We say that whenever evaluate it, we say that it's logical equivalent. And whenever you evaluate this statement, you say it's logical equivalent because it can be transformed to conditional statement by it can be transformed to bi-conditional statement. So whenever you evaluate this statement, it will give us tautology. There's no possibility of getting falsity, always truth. We say it's logical is tautology. Is tautology. Being justified by logical equivalent. Being justified by logical equivalent. We have done logical equivalent. So you can go to our previous tutorial on logical equivalent to get used to it so that you can be acquainted with it. So that you can be able to know what is mean by logical equivalent. Now, since we have now transformed it to bi-conditional statement and tautology, we can also transform it to conditional statement. You can also transform it to conditional statement and it will preserve tautology. That means if and only if P or Q implies not P implies Q. We have now transformed it to conditional statement. We have transformed it to conditional statement. And you find out that whenever the antecedent is true, whenever the antecedent is true, also the consequent must also be true. If you break this statement, there must be a negative falsity, always truth. You say statement is tautology. Because there must be a negative falsity. Whenever we this statement, always truth. You say that it is tautology. Because whenever the statement is true, also the consequent must also be true. You say is tautology being justified by logical implication. Being justified by logical implication. We have done logical implication in our previous tutorial. We can go back to our previous tutorial to gain knowledge or to know what is logical implication. So, being justified by logical implication. So, if and only if you find out that this P or Q, that means the antecedent, is a proper implication of not P implies Q, I mean the consequent. And if that is the case, since P or Q is a proper implication of not P implies Q, we say that P or Q exists. And if P or Q exists, we say that P or Q is logical implication of not P implies Q. That the antecedent is logical implication of the consequent, because the conditional statement is tautology. If it is case is tautology, we then know that it is certain that antecedent exists. So you say that P or Q is logical implication of not P implies Q. Not P implies Q. Now, P or Q is logical implication of not P implies Q. If this is true, this also must also be true. That means if and only if P or Q is equal to P or Q, being justified by identity. Being justified by identity. That means the logical application is equal to itself. And if logical application is equal to itself, it means that the logical application equal to itself is logical equivalent. It means that whenever the left hand side of P or Q is true, also the right hand side of P or Q is also true. In the same vein, whenever the right hand side of P or Q is false, also the left hand side of P or Q is also false. It says it's logical equivalent. Being justified by identity, that means the sameness. So if and only if P or Q is equal to not bracket P and the Q is still logical equivalent. That means P or Q is equal to not bracket P and the Q. Sorry, not bracket not P and the not Q. You see that this P or Q has been substituted with not bracket, not P and not Q is equal to P or Q. Being justified by the Morgan's law. By the Morgan's law. Being justified by the Morgan's law. If and only if P or Q is equal to not bracket. Now, this not P and not Q, we are going to intensify it. It's called intensification of law. Intensification of law. They want to intensify this statement. That means not P and not Q. You want to increase the value so that not P and not Q will be a subset of the increase in the value. That to say, P implies not Q. P implies not Q. We have now increased the value of not P and not Q to be P implies not Q. The value has now been increased. Now, since value has now been increased, then when you negate it, it will extenuated. When you negate it, it means that it will now be extension of this not bracket, not P and not Q. That means the value will now decrease. It will no more equal to P or Q. That means not bracket, not P and not Q. It's no more equivalent. It's not grace, because this not bracket, not P and not Q is greater than not bracket P implies not Q. Because this will give us, this is equivalent to P and the Q. It's equivalent to P and the Q. Why this not bracket, not P and not Q is equivalent to P or Q? You see that the electrical equation now is now a superset of the right equation, which is P and the Q. So we say is acceleration, we call it, we say is extenuation of P or Q. That means not bracket P implies not Q is decreased in value, is microcosm. That means of P or Q is extenuation, decrease in value of P or Q, being justified by Christ Almighty, God's grace. Christ Almighty is not grace, is grace. Called Christ Almighty, God's grace. That is what you use to transform this not P and not Q to this social statement. P implies not Q. Being justified by Christ the Almighty, God's grace. Because this not bracket, not P and not Q is grace, because this is facet of this. That means not bracket P implies not Q. That's why it say is grace. So, but this is being intensified. This not P and not Q is now being intensified. As in not bracket, not P and not Q is now being intensified to be not, sorry, this has now been estimated. This not bracket, not P and not Q, it has now been estimated, it has now been decreased in value to not bracket P implies not Q. If and only if or Q is equal to. Now, this not bracket P implies Q is going to be signified. Is going to be signified. That means what means by signification is that we are going to negate all the whole statements that is involved in this. Not this P implies not Q. That means whenever a statement is negative, it's going to be positive. Whenever a statement is positive, it's going to be negative. Here we have P. It's going to be, that means this not will then negate it, it becomes not P. The implied will remain the same. The implied will remain the same. Then this not will negate this not Q. You have not Q, which is set as Q. You have now negated it. Now you see that this statement now has now been intensified again. It has now been increased in value, which makes it to be equal to the left side of equation. That means this statement now, this statement decrease, then increase it again, it becomes not P implies Q. Now that's now changing in syntax. First of all, here, from here to here, the syntax change and value change. Here to here, the syntax change and the value also change, making it to be equal to P or Q. So it's now logical equivalent. So being justified by signification of law. Being justified by signification of law. So the difference between signification of law and the most law is that the most law will affect the collective, but in signification of law, it does not affect the collective. Now I have now proved that P or Q is equal to not P implies Q. We then say thus, we conclude, thus P or Q is equal to not P implies Q. Since it is not equivalent, we are going to prove the converse. We are going to prove the converse, so that by the principle of externality, we then establish that P or Q is equal to Q upon not P equal to not P implies Q. Is first Ejike's law. So we're going to prove the converse. Conversely, not P implies Q is equal to P or Q. Now this is the converse of P or Q equal to not P implies Q. You have seen that this not P implies Q at the right side of equation now has become not P implies Q at the left side of equation. Also, this P or Q at the left side of equation has now become P or Q at the right side of equation here. That means it is converse. I'm going to prove the converse. So suppose Suppose P, suppose not P implies Q is equal to P or Q. We assume that it is true that not P implies Q is equal to P or Q. And it is true. As a hypothesis. Now, since this statement is logical equivalent, that means whenever the left side of the equation is true, also the right side of the equation is also true. Whenever the right side of the equation is false, also the left side of the equation is also false. This is logical equivalent. And it is true in this case that it is logical equivalent. Since logical equivalent, we are going to transform it to biconditional statement. If and only if not P implies Q, if and only if and only if P or Q, you have now transformed it to biconditional statement. And you see that whenever the left equivalent is true, also the right equivalent is also true. Whenever the equivalent is false, also the equivalent is also false. You say that. So that whenever we want to write this statement, there's no possible identity falsity, always true. You say it's logical equivalent. Sorry, say that it is tautology. Say it is what? It is tautology. It is tautology. Oh, sorry, let us continue to, so that it will be visible. Let's continue to this side. That is, if and only if not P implies Q, if and only if P or Q is tautology, being justified by logical equivalence. Being justified by logical equivalence. If and only if. Now, we are going, since this statement is in biconditional statement and tautology, we also going to transform it to conditional statement, and it will still preserve tautology. That means not P implies Q implies P or Q. You see that whenever you have now transformed it to conditional statement, and whenever not P implies Q is true, that means antecedent is true, also the consequent is also true. So if you break this statement, that was negative falsity, always truth, you say that it is tautology. Statement is tautology. Is tautology. Being justified by logical implication. Now, this statement, not P implies Q, implies P or Q is tautology. We then, this is certain, not P implies Q exists. So it is certain that antecedent exists because the statement is tautology. The conditional statement is tautology. We said that it is certain that not P implies Q exists, because not P implies Q is a proper implication of P or Q. Since not P implies Q exists, we said not P implies Q is logical implication of P or Q, and is the consequent. If and only if not P implies Q is logical implication of P or Q. We say that not P implies Q is logical implication of P or Q. If it's true that not P implies Q is logical implication of P or Q, also this must also be true. If and only if not P implies Q is equal to not P implies Q. That means the logical equivalent is equal to itself. And if it is equal to itself, it means that it is logical equivalent. The equation is logical equivalent. That means not P implies Q is equal to not P implies Q is true. Because whenever the left side of the equation is true, also the right equation is also true. Whenever the right equation is false, also the left equation is also false. It says it's logical equivalent. So we justify by identity, the sameness. Being justified by identity. That means the sameness. We continue to this side. If and only if not P implies Q is equal to not bracket is equal to not bracket P implies not bracket P implies not Q. So we have now signified this not P implies Q. And let's simplify it. It gives us not bracket P implies not Q. That means here, but whenever anywhere a statement is positive, it becomes negative. Anywhere it is negative, it becomes positive. Here it is positive here, it becomes negative here, not Q. Here it is negative here, it becomes positive here. That means P. Here is positive, it becomes negative here, not Q. Here it is negative, it becomes positive here. That means Q. Not bracket P implies not Q. Now I classify it. It's no more equivalent. Whenever we simplify a statement, that statement is no more equivalent. It's no more equivalent. Either it is intensified or it extenuated. Either it is intensified or it is extenuated. So here, the statement has now been extenuated. It has now been extenuated. We say is extenuation of not P implies Q. Because this value This factor of the equation has now been decreased. It's now equal to P and the Q. So if and only if, so we justify by signification of law. Being justified by signification of law. If and only if not P implies Q is equal to. Now, we are going to transform this not P implies not Q to conjunctive statement using Christ Almighty God's grace. That means P implies not Q is going to intensify now. I'm going to intensify it. If you intensify it, it becomes not bracket, not P and not Q. So P implies not Q has not intensified by Christ Almighty God's grace. You see that this statement has now P implies Q is a summation of not P and not Q. So its intensification that P implies Q is increase in value of this not P and not Q. So it's a facet of not P and the not Q. We have seen that by increasing the value of P implies not Q, we have now made it has now become equal to the left hand of the equation. So being justified by Christ Almighty God's grace. Christ the Almighty God's grace. So is equal to not P implies Q is equal to P or Q. You see that not bracket, not P and not Q is equal to P or Q. They are equivalent. So by De Morgan's law, not bracket, not P and not Q is equal to P or Q. And is equal to the left side of the equation. So we justify by the Morgan's law. We justify by the Morgan's law. If and only if you say now you have now proved the converse, not P implies Q equal to P or Q. That means you have now proved the converse. We say thus not P implies Q is equal to P or Q. P or Q. Having proved the converse now, we can now establish that P or Q is equal to Q upon not P is equal to not P implies Q is first Ejike's law. Therefore, by principle of externality, we then establish that P or Q is equal to Q upon not P is equal to not P implies Q is first Ejike's law. Therefore, P or Q is equal to, when we are establishing our hypothesis, we remove Q upon not P to manage our space. Now I'm going to introduce it again. You have Q upon not P is equal to not P implies Q. That is first Ejike's law. We have now proved that first Ejike's law exists. Try to say P or Q is equal to Q upon not P is equal to not P implies Q. Thank you, viewers.